Okay, good afternoon, Year 11. Um, Lesson 1 on magnetism. Okay, 5 quick questions. What do you remember? Take a pause and have a look at those now. Okay, and coming back in, let's move on. We should know these basic facts about magnets, north-south pole, north and south, and a few of the magnetic materials you may know, but today we're just going to go over the basics. So, here we go. Magnetism has been known about for centuries and centuries, and the first people to really think about magnetism were the ancient Greeks. Here we go, we've got Thales. He lived about 2,500 years ago, and he actually knew about magnets because magnets occur naturally in an iron iron ore called lodestone, which is magnetic. And he investigated with magnetism. He also looked about with static electricity too. Okay. Moving on, Chinese in the 4th century. They wrote about magnets and they knew how to use them as a compass. Pretty smart. Okay, and about 1,000 years ago, there was a Chinese scientist, Shen Kuo, who wrote about magnets and how to use lodestone for navigation. And that probably enabled the Chinese to be the first people to actually get to America. Okay, it wasn't Europeans, it was the Chinese. Go and research it. It's quite an interesting little fact. Okay, and then moving on, we were quite late in Europe getting knowledge of magnets. So we were talking about the 13th century there, and moving on up to more present day, Ørsted, who you will learn about in the next lesson. He mucked about with electricity and magnetism because there is a link there. Okay, so let's move on. All of these are metals, but only some of them are magnetic. Or rather, all of these are materials and only some of them are magnetic. So let's dip a magnet in, and these are the three naturally magnetic elements: iron, cobalt, and nickel. Now, steel is magnetic because steel is made out of iron with a little bit of carbon added. It's an alloy. But these are the three magnetic elements that you should know: iron, cobalt, nickel. The magnetic rules you should be familiar with. You should know that opposite poles, north and south, will attract. North and north will repel. So will south and south. And we can write this into a very simple rule in one sentence. Unlike poles attract, like poles repel. Very, very simple. Okay. Moving on, looking at a magnetic field, one of the things that you need to be able to do and describe is how to see a magnetic field. That's done very easily. Here's a magnet. This was me in the lab. Let's just play it. Okay. The Williams off there, which is good. So I've got a sheet of paper, covered a magnet, got some iron filings, and simply sprinkle them over the top. And the iron particles, they actually line up with the magnetic field of the magnet. And if I just pause that there, you can see quite clearly we've got these structures here, which are shown in the diagram. Okay, so that's how we see a magnetic field. There we go, and I was just tapping that off to make the field nice and clear. Okay. Another way we can see a magnetic field is to use a plotting compass. So here we go, we've got a pair of magnets, and notice how the magnetic force from the north and the south polar, notice how they join because a field flows from north to south, north to south. And as we move a plotting compass around, you will notice that the plotting compass always points in the direction of the field. So if I move this anywhere here, it's always pointing in the direction of the field. And the field flows from north to south. Okay, I'll put it down there. And I can just muck it. There you go. I'll put it there. It always follows the direction of the field. So we can actually plot a field using a plotting compass. Okay. So we know that a magnetic field surrounds a magnet, and this is a magnet with some iron filings that have been sprinkled around it. And you notice the ends of the magnet are where most of the iron filings are attracted, and they are the strongest parts of the magnetic field. And that is because the field lines, if you notice, are much closer together at the poles than they are around the magnet. And it's the relative closeness of the lines which tells you how strong the field is. Let's move on. Something else you may recall from Key Stage 3, you might have had a go at it yourself. We know that magnets pick up objects that are magnetic materials, and it does this because a magnet will induce a magnetic field in a magnetic material. That means, for example, here is a steel nail. It's not a magnet, but if we bring it towards the magnet, we know it will be attracted. And the reason this happens is because when this nail comes into the magnetic field, it itself becomes a magnet. We induce a magnetic field in the nail. And if you notice, that becomes north, and that becomes south, and that's why it attracts. So we can actually induce a magnetic field. A bit more about magnetic fields. You may notice that we know that compasses point north and south, and we know that a compass is a north pole there and a south pole there. A little compass is a magnet, and the reason it points north and south is because the Earth is surrounded by a magnetic field. Now observe, look at this magnetic field of the Earth. You will notice that the north pole of the Earth, which is where Father Christmas lives, okay, is actually the magnetic south pole of its magnet. So this is why a compass always points north, because it's attracted towards the south pole. It's following the line north, north. Okay, that's something to a little puzzle over. And another fact about the magnetic field: if it wasn't for the magnetic field, there would be no life on our planet. Magnetic field shields a lot of harmful rays from the sun. And here we go. This is what happens to our magnetic field. It gets battered by the sun, and it extends over millions and millions of kilometers behind in the shadow of the Earth opposite the sun. Okay, good. Now, a bit of reading for you. This is in the files. It's under a document called magnetic text.doc, I believe it's called. It's in the files and in chat. Read that through. That's all the basics of magnets. And then you are going to do my questions. So these are my comprehension questions, not the ones from the text. So if you can't see that, pause it now and have a go. Okay, and I'm going to unpause in a moment and look at the answers. And let me tell you, I would like to see your answers in class note. And I've actually put these questions already in. I've actually distributed a document into your class note so that you can answer the questions directly in there. So let's go through the answers. There we go. Nothing too challenging there. Take a pause, correct your answers. Obviously your answers will be in full sentences. I've just put the key points down that need to be in your answers. So pause that and correct it. And let's unpause. Okay, so these last two questions, sketching a magnetic field, obviously it won't look like that when you sketch it because that's far too complicated. So just a quick one here. Look, in an exam you may be given a blank magnet and asked to sketch the field. All we need to do is to show that we have field lines coming out of the north, pointing that way. We have field lines coming into the south, and we have a magnetic loop there. We have a magnetic loop here, look. And notice that the arrows always go from north, out of the north, towards the south. Okay, so that would actually get you 3 marks in an exam. Okay, so that's something like that. Okay, so I'm going to pause there now. Make sure your work goes into Teams. Let's just get rid of that. I'm sure I've got another slide. There we go. So make sure you complete the work in the class note. And there is also a form which I've assigned during this lesson where I would like you to submit any questions that you have. Okay, you've got to submit at least one question, and that will form the register for this period, period 5. Okay, once you've done that, take a 5-minute break and then come back in. And at 2 o'clock, sorry, 2:10, I will lead off on session 6. Okay, so enjoy.